Good morning, it's 9/11. We appreciate you watching Minnesota Live. Big thank you to Kelly Hansen this morning for filling in for Megan.
Thanks for having me.
She'll be back tomorrow.
All right, the University of Minnesota Twin Cities is a top 10 U.S. public research university. And there you're going to find Minnesota natives, originally from Faribault and Austin, who were first-generation college students and the first doctors in their family. And they are currently, they operate a transitional genome engineering research lab together. Big words doing really cool things.
You're right about that. Doctors Brandon Moriarty and Bo Weber are the team behind the U of M's Center for Genome Engineering, and they're making headlines with their abilities to get technology into the clinic to help cancer patients, being the ultimate goal. Gentlemen, thanks for joining us.
Yeah,
thanks for having me.
Good to see you. We met a couple years ago.
We did, yeah.
So good to see you again. What's going on in the lab right now?
Yeah, we're still working on developing new therapies for advanced cancers. And we're excited to kind of announce that we finished our first trial, which had some excellent outcomes, and we're now ramping up for our next clinical trial.
Okay, there's something called, there's a genome engineering, and you guys are looking at modifying the genetic code to help the immune system fight cancer. The immune system plays a big role in developing cancer, right? Maybe, Brandon, you can answer that.
Yeah, definitely. And it's not known widely, but your immune system is your best defense against cancer. And it's really only when your immune system fails to identify and eradicate early developing cancer that it's clinically detectable and they go into treatment. And so really, that's the exciting part of our work, is we really focus on how can we leverage the immune system to fight existing cancer.
Okay. Bo, can you give us a layperson's description of what genome engineering is?
Yeah, it's essentially where we use these technologies that have been really developed over the past 10 or so years to modify the DNA within cells. And we do this to really modify their functionality. In the case of what we're doing it to improve the function of the immune system to fight cancer. But there are many other uses, including at the Center for Genome Engineering at the University of Minnesota, where there's a whole group of faculty that work and use genome engineering to study everything from basic biological processes to more like what we're doing, where we're using this to soup up the immune system to make it better equipped to fight cancer and treat other diseases.
Okay, Brandon, you kind of mentioned this. You alluded to this first of its kind clinical trial using tumors. What did you guys do here?
Yeah, so when a person gets a solid tumor cancer, your immune system tries to eradicate it. So they actually infiltrate into the tumor. But when they're failing to eradicate it, they become exhausted and kind of suppressed by these cancer cells. And so what we've done is we actually take out a little bit of tumor, extract those immune cells or T cells that are trying to fight the tumor but are failing, and then we use genome engineering to edit their genetic code to essentially make them better, faster, stronger. We grow them up to billions in number, and we reinfuse them into the patient to fight their cancer.
So you're basically putting the tumor with the good stuff, the good guys kind of back in to fight the solid tumor there.
That's right, yeah.
That is so wild.
What would normally explain sort of the immunotherapy versus, let's say somebody's sick with cancer and they have a tumor. Historically, they'd be treated with chemotherapy, which is inherently bad for the body.
Mm-hmm. Yeah, absolutely.
And so then how does this differ?
Yeah, so this is really unlocking a natural process, and so really what the goal with these immunotherapies is to be able to eventually get away from using radiation or chemotherapy, some of these really harsh treatments. And one of the ways that immunotherapies are able to do that is by increasing the precision of the targeting of the tumor, rather than just using something that kills every cell that divides fast. You're actually using immune cells that are evolved basically to very specifically go after the tumor itself and leave healthy tissue alone, essentially, is the ultimate goal.
And what's really, really exciting is I understand you guys have had some incredible results with this, right?
Yeah, as I mentioned, we just finished our clinical trial. We treated 12 patients with highly advanced metastatic GI cancer. So this was like their last opportunity for a therapy. And over half the patients, their tumors halted growing completely. And we had one patient where all of her metastases and tumors just melted away. She's been cancer-free for over 2.5 years. And so now we want to do this again in a follow-on trial with even hopefully better results.
So how long does something, explain the process, how long does something take to go from clinical trial to practical applications, where if somebody's watching at home right now and they know somebody who's suffering from cancer, they might be able to be helped by that?
Yeah, so, you know, what we did with our initial clinical trial was establish the proof of concept and safety of using genetically modified TIL. And so our goal within the next 2 to 3 years, with continued support, is to initiate another clinical trial where we're actually going to increase, our goal is to increase the accessibility, the efficacy of this therapy for additional types of cancers. And in the next 2 to 3 years, we want to launch a trial where we're going to treat patients with sarcoma, ovarian cancer, breast cancer, liver, lung, and GI cancers using advanced techniques that we've developed in the lab. And that's really comes down to why we're launching this Minnesota TIL Alliance, where essentially we're working until it's cured to move this goal forward.
This is going to help so many people. The TIL is tumor infiltrating lymphocytes, and that's what the TIL means. So this next clinical trial, you mentioned so many different kinds of cancers: ovarian, breast, lung, liver, GI. This is going to help so many people potentially, and not just here in Minnesota. We're talking everywhere, right? I mean, people can get involved, hopefully, from all over the country, all over the world. Is that the idea?
Yeah, absolutely. And all of these patients, again, will be kind of in the worst shape, kind of end stage. And this is really one of the only therapies in the world that can cure that type of advanced cancer.
Wow.
And you guys both donated blood for this particular study? Or one of the studies that you did?
Yeah, it's interesting. Part of the manufacturing process, I won't get into the details, but these immune cells, when we take them through the final stage where we grow them into billions in number before they go in the patient, they actually need what we call feeder cells. It's like moral support for these TIL to grow to really large numbers. Yeah. And we use healthy donated blood to do that. And so Brandon and I both went in and donated a pretty large quantity of blood
to create a bank.
To create a bank.
Not all at once, obviously.
Yeah, no. So, but we were happy to volunteer to do so.
This is incredible. I mean, really incredible work. Congratulations on your success. And I know I'm excited to see where this goes. I'm sure you are too, just because cancer.
Well, I was going to mention
so many of us.
When we met, we interviewed these guys several years ago, 4 years ago, I think, and we were talking about Zach Sobiak because Zach died of cancer, and he had a sort of a connection to the gentleman we see who was one of the workers in the lab. Is he still in the lab right now?
No, actually, he's in MD PhD school right now.
Okay.
Yeah, Mitchell. Yeah.
Smart guys.
Very.
Yeah. Well, you guys are definitely making a difference.
Yeah.
So good to see you. Thanks for stopping by again.
Yeah,
thanks for being here. Really exciting work. Okay, we've posted a link to the Center for Genome Engineering's Until It's Cured page on MinnesotaLive.com. There you're going to learn more about the doctors, donate to help them in cancer, and learn more about those clinical trials that they've completed.